To truly grasp the enigma of Neptune's great dark spot, we must first journey to the cold frontier, an astonishing 4.5 billion kilometers from the Sun, or 30 times farther than Earth, at 30 astronomical units. For centuries, Neptune was imagined as a frozen cipher, a pale azure smudge asleep in profound cold at around -200 degrees Celsius. Its atmosphere assumed to be static due to receiving only about 1/900th the solar energy per unit area compared to Earth. Atmospheres, we believed, required significant solar energy to drive dynamic weather patterns. Without it, only monotonous calm could exist. But our assumptions were profoundly wrong. Then came August 25, 1989. The Voyager 2 spacecraft, after a 12-year journey and closest approach just 5,000 kilometers from the cloud tops, offered humanity its first close-up look at this distant ice giant. What Voyager 2 revealed was not a frozen cipher, but a roaring world alive with supersonic winds reaching up to 2,400 kilometers per hour or 1,500 miles per hour, the fastest in our solar system. The centerpiece of this tempestuous realm was the Great Dark Spot, a colossal anticyclone in the southern hemisphere, measuring roughly 13,000 kilometers across, nearly the size of Earth at 12,742 kilometers in diameter. This wasn't merely a cloud formation. It was a vast hole plunging into Neptune's hydrocarbon abyss, appearing as a dark elliptical void in the deep blue methane haze due to lower cloud layers exposing darker hydrocarbons below, a majestic and terrifying vortex. Accompanying the Great Dark Spot were bright, compact cirrus clouds, dubbed scooters, moving at speeds up to 400 meters per second faster than the spot itself. This presented a profound crisis for planetary science. How could such a dynamic storm exist on a planet receiving only 1/900th the solar energy of Earth? The energy drop-off is drastic, as shown in the graph. Unlike Jupiter's Great Red Spot, which is stable for over 360 years and about 16,350 kilometers wide, fueled by internal heat, Neptune's GDS 89 seemed to defy conventional understanding. The hypothesis emerged that Neptune's internal heat, estimated at 2.61 times its absorbed solar energy from a potentially 5,000 Kelvin hot rocky core, must drive these powerful winds from below, fueling deep convection. We named it GDS 89, and like Jupiter's enduring storm, many assumed it would be a permanent fixture in Neptune's turbulent skies. But Neptune, as we would soon learn, is a planet of wild, untamed nature, far less viscous and predictable than its gas giant cousin Jupiter. In 1994, the Hubble Space Telescope turned its gaze towards Neptune, seeking to observe the familiar Great Dark Spot. What it found was astonishing. GDS 89 was gone, completely erased. The colossal storm had simply vanished between May and July of that year, as confirmed by Hubble images in June and November. This phantom storm, once thought permanent, had formed and faded, likely due to viscous dissipation or interaction with powerful zonal jets. Neptune's atmosphere proved to be a shapeshifter, its storms transient, its dynamics a constant dance of generation and destruction. New dark spots would emerge, like the smaller Northern Dark Spot, or NDS, one in 1995 at about 2,500 to 3,700 kilometers wide, and another southern spot designated S1 in 1994 to 1995, continuing the cycle. These storms typically generate near 55 degrees north or south latitude, drift equatorward at a slow pace of about 0.15 meters per second, and are ultimately shredded by the planet's high-speed equatorial jets reaching up to 400 meters per second. Time-lapse simulations reveal their violent life cycle, forming, drifting, and being destroyed within 3 to 6 months. The story of Neptune's Great Dark Spot is a humbling reminder of the universe's fluid and transient nature. In the cold, distant reaches of our solar system, we find not static monotony, but a restless, untamable nature, constantly reshaping itself. As new missions and technologies emerge, a new eye is opening, promising to unveil even more of the cosmos's profound mysteries.